Hello guys, in this video we are going to discuss the solution of the problem maximize the cut segments. So let us look at the problem statement. The problem statement says given an integer n denoting the length of a line segment, you need to cut the line segment in such a way that the cut length of a line segment each time is either x, y or z. Here x, y and z are integers. After performing all the cut operations, your total number of cut segments must be maximum. Return the maximum number of cut segments possible. So let us try to understand this problem with the help of an example. So let us say the value of n which is given to us is 4 and the values of x is 2, y and z equals to 1. So in this case, the line segment of length 4 can be cut into 4 line segments, each of 1 unit. So these are the line segment. This is my line segment 1, this is my line segment 2, 3 and 4. And that is why for this case we are going to return 4. There is one minor detail which we need to understand, which is, let us say if the value of n equals to 7 and the value of x is 5 and y and z equals to 2. So in such case, the line segment AB of size 7 can be cut in a maximum of 2 parts, which is one of line segment 1 of length 5 and another of length 2. And the thing which we need to be aware of over here is the line segment AB of length 7. For this is not a valid cut. So let us say each of these cut is of size 2 and this one is of size 1. So as you can see, this line segment is of size 1, because of which this is not a valid segment and this is not a valid cut. And this is one minor detail which we should be aware of in order to solve this problem. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example and let us say n equals to 7 and x equals to 5 and y and z equals to 2. And our objective is to find the maximum number of cut segments. So let us see how we will be able to do this. Well, in order to solve this problem, we are going to use a DP table, and the size of this DP table will be n plus 1. And let us see how with the help of this DP table we will be able to find the maximum number of cut segments. So here what we are going to do is we are going to follow bottom-up approach, which is we are going to solve this problem for n equals to 0. Then we are going to solve it for n equals to 1, then for n equals to 2, and similarly all the way till n equals to 7, and we will get our answer. So let us see how we can solve this. So the first case, which is n equals to 0, is also our base case. In this case, the length of the line segment given to us is equals to 0. In such case, it is not possible to cut the line segment, because of which dp of 0 will be equals to 0. And folks, please recall the value of x equals to 5, y and z equals to 2. So let us proceed forward. Now, the length of the segment is 1 and we want to cut a segment such that the resultant line segment which we obtained is either of size x, y or z. Or one of these segments should be of this size, as all the values of x, y and z is greater than n, because of which dp of 1 will be equals to minus infinity, which simply indicates that it is not possible to cut the line segment. Now, when the line segment is of length 2, then it is possible to cut the line segment into just one part, which is the entire line segment can be considered as a cut of either y or z, because of which dp of 2 will be equals to 1. Now let us work on n equals to 3. For n equals to 3, we have just one option, which is to divide the line segment into two parts, one of size 2 and another of size 1. So over here, the line segment of length 3 got divided into two parts. One is of length 2, so this is of length 2, and another is of length 1. And recall from our discussion, this is not a valid cut, because of which dp of 3 will also be equals to minus infinity, indicating that it is not possible to make a valid cut over here. Now let's move forward. Now let us look for n equals to 4. Now when n equals to 4, there is again just one possibility, which is a cut of 2. So when we make a cut of 2 unit over here, so this becomes equals to 2 and this also becomes equals to 2. So in such case, it is possible to make a valid cut and the total number of cuts we will get is 2. Now how can we use our DP table in order to compute this? Well, the way we will be able to do this is dp of 4 is equals to 1 since we are making one cut plus dp of 4 minus 2. This 4 is the total length of the line segment and this 2 is the cut which we have made. So now the remaining length of the line segment is 2 and for which we want to solve. So this will be equals to 1 plus and dp of 2 as we can see over here is 1. So this will be equals to 1 plus 1 and the value will be 2. Now let's work with n equals to 5. When n is equals to 5, we have two options over here. Either we can make a cut of 2 or we can make a cut of 5. Now if we make a cut of 2, then this will be equals to 1 plus dp of 3, and if we make a cut of 5, then this will be equals to 1 plus dp of 0. And this 3 is essentially 5 minus 2 and this 0 is 5 minus 5. And the reason why we are adding 1 to it is because we have made a cut of 2 and 5, because of which this one is coming over here. Now since dp of 3 and dp of 0 is already solved, so let us look at our dp table to get our answer. So over here this will be equals to 1 plus minus infinity, dp of 3 is minus infinity, and this will be equals to 1 plus dp of 0 equals to 0. So this value will be minus infinity and this value will be 1. And since our objective is to find the maximum between these two, so the maximum will be this value, which is 1, because of which dp of 5 will be equals to 1. Now let us move forward and let us solve for n equals to 6. So again we have two options with us, which is either we can make a cut of 2 or we can make a cut of 5. If we made a cut of 2, then the length of resultant segment will be 6 minus 2, which is equals to 4. And if we make a cut of 5, then the resultant line segment length will be 6 minus 5, which is equals to 1. So this becomes equals to 1 plus, so the value of dp of 4 equals to 2. So let's have 2 over here, and similarly this will be equals to 1 plus the value of dp of 1. So let us look at our dp table. So the value of dp of 1 is negative infinity. So this will be negative infinity. So from here we get 3 and this will be equals to negative infinity. And since we have to find out the maximum, so dp of 6 will be equals to 3. Now let us look for n equals to 7. So for n equals to 7, again we have two options with us. We can either make a cut of 2 or we can make a cut of 5. Now if we make a cut of 2, then the resultant segment length will be 5. And if we make a cut of 5, then the resultant segment length will be 2. Now let us use the values over here. So this will be equals to 1 plus dp of 5. And dp of 5, as we see, the value is 1. So this will be equals to 1 plus 1. And in this case, the value will be 1 plus dp of 2. And the value for dp of 2 is 1. So this will be equals to 1. So from here we got 2 and from here also we are getting 2. And the maximum of 2 is 2. And this value is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find out the maximum cut and n, x, y and z is given to us. So the first thing which we are going to do is we are going to take a dp table, and the initial value of this dp table will be minus infinity. And what is the size of this dp table? Well, the size of this dp table is n plus 1. Then let us initialize our base case. So dp of 0 will be equals to 0. And then we are going to use the bottom-up approach of dynamic programming in order to solve this problem. So for that reason, for I in range of 1 to n plus 1, and let's have three variables with us. and the initial value of these three variables is minus infinity. And now let us see whether it is possible to make a cut of x or not. So if I minus x is greater than or equals to 0, then it is possible to make a cut of x. Now if we have made a cut of x, then the value of a will be 1 plus dp of I minus x. And the same thing we are going to do for b and c as well. So if it is possible to make a cut of y, then in such case, value of b will be equals to 1 plus dp of I minus y. Similarly, if it is possible to make a cut of z, then I minus z will be greater than or equals to 0. In such case, c will be equals to dp of 1 plus dp of I minus z. And in this way, we will be able to find out the value of a, b and c. Now, what will be the value of dp of I? Well, the value of dp of I will be equals to maximum of dp of I, the existing value, or the value of a, b and c. So the maximum of these four values will be the value of dp of I. And towards the end, all we have to do is we need to return maximum of dp of I, comma 0. And in this way, we will be able to find our maximum cut. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So for this, we need a dp table of size n plus 1, and the dp table is initialized with negative infinity. Then the base case where dp of 0 equals to 0. Then we are iterating on I for I in 1, 2 and plus 1. Then the values of a, b and c. And once we have populated the values of a, b and c, then towards the end we are finding the maximum of a, b and c and dp of I. And then we are returning the maximum of dp of n, comma 0. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at our C++ solution. So the C++ solution is also the same, folks. Again, we have a dp table, and all values of dp table is initialized with int minimum. Then the base case where dp of 0 equals to 0. Then the bottom up approach in order to solve this problem. And we are computing the values of a, b and c. Which is, if it is possible to make a cut, then we will make a cut and we will compute the corresponding value. And in order to update the value of dp of I, we just have to find the maximum between those four numbers. And towards the end, all we have to do is we need to return the maximum of dp of n, comma 0. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.